Hello everyone, today I'll show you something that still feels a little bit like magic, how to build a whole Salesforce app just by talking to an AI, no clicking through menus and no writing code by hand, just a conversation. I'll explain how it works, set it up step by step, and then build something live in this video. But first let me clear up a common misunderstanding about MCP because a lot of people get it wrong. When people hear Salesforce MCP, they think Salesforce invented the MCP, but they didn't. And some people think that it only works with cloud. It doesn't. So let me explain what MCP really is. MCP stands for Model Context Protocol. Think of it like a USB port, but for AI. Here is the problem it solves. In the past, if you wanted an AI to talk another app, your email, your database, your CRM, someone had to build a special custom connection every single time. It was slow and it didn't scale. MCP fixed that. It's one shared language, so any AI and any app can just plug in and work together. And here is the key part. Anthropic, the company behind Claude, created MCP. But they made it open for everyone. They gave it away as a free, open standard back in November 2024. That's why it spread so fast. Today it's not just cloud. OpenAI, Google, Cursor, GitHub, Slack, Notion, a lot of big names, even direct competitors, all speaks the same MCP language now. That's the beauty of it. It's open and neutral. So where does Salesforce fit in? Salesforce didn't make the MCP protocol. They built a server on top of it. They launched Hosted MCP Servers as a beta in October 2025, and it went fully live in April 2026. Salesforce Hosted MCP Servers are now generally available in April 2026. They even published a special guide just for connecting cloud in May 2026, just 2 months ago. From Salesforce, Philip Özil explained how we can connect our Cloud AI to Salesforce step by step on this page. And that tells you something important. Connecting cloud to Salesforce is official and fully supported. It's not a hack or a workaround. And since Salesforce built it themselves, it's safe by design. Cloud connects through Salesforce's own secure login, and it can only do what you give it permission to do. Your data stays inside Salesforce's own security. Nothing is exposed. So this is really new. Quick summary. Anthropic made the language, Salesforce built the server, Cloud is the guest that connects. And that's exactly what we are doing today, connecting Cloud to Salesforce so I can build a real app just by chatting. The links are below, the official links are in comment. Let's go. Okay, so here we are. This is Cloud on Claude AI. This is the tool that's going to build our Salesforce app for us. But right now there's a problem. Cloud and Salesforce don't know each other yet. They've never met. So our real job today is to introduce them, to connect the two. To do that, we go to connectors here on the left. As you see, Cloud already connects to a lot of popular tools like Gmail, Google Drive, Slack, GitHub. These all work through that same MCP idea we just talked about, but Salesforce isn't in this list, so we are going to add it ourselves. Up here on the top right, we click Add and then choose Add Customer Connector. Custom just means it's our own. We are bringing to our own Salesforce server. And when we open it, you will see it asks us for just 2 things. A server URL, that's the address of our Salesforce MCP server, and a client ID, that's like ID card that proves who's connecting. Here's the catch, we don't have those 2 values yet. Both of them come from the Salesforce side. So we can't finish here, not yet. First, we need to jump over to Salesforce, set a few things up, and grab those two pieces. Then we'll come right back to this exact screen and paste them in. So let's leave Cloud open for now and head over to Salesforce. Okay, now we are inside Salesforce on a page called the External Client App Manager. Let me explain what this is in simple words. Remember, we need to let Cloud into our Salesforce org. So we are going to make Cloud a kind of ID card, an external client app. This card is what lets Cloud log in and prove who it is. You can see we already have one here called self-deploy, but that one has a different job. It's for the org token to itself. For Cloud, we'll make a fresh, separate one. It's cleaner and safer to keep them apart. And here is a quick note on why we need this app. Why we need this app? It's because we are connecting from Cloud in the browser, from Claude AI. The web needs a secure official login, and that's exactly what this app gives us. If you were using Cloud Desktop with a local service running on your own computer, you could just use your Salesforce CLI login and skip this whole step, self-deploy step. You can skip it. But we want to build Apex classes and triggers right from the Cloud chat in the browser. So for that, we do need to set up this app. So let's click New External Client App in the top right. First, the basics. I will give it a name, Claude MCP. As a contact email, I will use this email, and distribution state will be local, and the other all stuff, symbol stuff, just so we can recognize it later. And the next step is API, enable OAuth settings. OAuth means open authorization. OAuth is just a secure standard way for one app to log into another, the same way you sign in with Google somewhere. So we are saying, yes, this app is allowed to log in with this checkbox. Now, the callback URL, this is the address Cloud comes back to after logging in. Salesforce even gives us Cloud's exact address to paste here. This is the callback URL address. That actually tells you this is officially supported. Then the most important part, OAuth scopes. This decides what Cloud is allowed to reach. And we are keeping it tight. We only pick two: access to the MCP servers and permission to stay connected. We are not giving full access to everything, just what it needs, nothing more. That's actually good security. We are choosing from here first, perform request at any time, refresh token offline access. And secondly, we'll choose that access Salesforce hosted MCP servers, MCP API, and we are sending these two to selected OAuth scopes. Down in security, we turn on PKCE, require proof key for code exchange. Think of it as a one-time secret code, so no one can steal the login in the middle. We also turn on JWT, which is just the format Salesforce wants, and we turn off the require a secret option because Cloud runs in a browser and can't safely hold a secret. PKCE does that job instead. Down here, we have also web app, canvas app, mobile app, or other two options. Everything else on this page, mobile canvas single sign-on, we don't need, so we leave it closed. Then we click create. Last thing we grab here, we open settings, find the consumer key and secret under OAuth settings, and copy the consumer key. That's the first of our two values. It is the ID Cloud will use. We'll paste it into Cloud later. Now we are going to the MCP servers page. We already have our ID card ready, the consumer key from the external client app, but an ID card alone is not enough. We still need to build the actual server that Cloud will connect to. So let's search for MCP servers in setup and open it. And here, a nice surprise, Salesforce already gives us a few ready-made servers out of the box for reading and creating records. But we don't want to generic ones. We want to expose our own tools, the ones we built specifically for this. So we are going to create a custom servers. But first, what actually are these tools? Let me show you where they come from. These are Apex classes code we deployed into Discord beforehand, before the demo even started, 6 of them. Each one does exactly one job, creates Apex classes, creates custom objects, creates triggers, run test, insert records, and lastly, builds a whole app. Let me open one Apex class developer. And here's the magic word, this invocable variable and invocable method. When you mark an Apex method as invocable, Salesforce can expose it as an Apex action. And that's what lets it become an MCP tool. No connector code, no plumbing, just that one line. So now let's build the server. Add MCP server, create Salesforce MCP server, we'll click and give it a simple name. I will write Apex deployer, and I will give same thing to description. I will click create, and this is our MCP server Apex deployer. This name become part of the web address. Then we open add tools, and here they are, our 6 Apex action. We add all 6, create records, deploy Apex class, deploy Apex trigger, deploy whole app, deploy custom object, and run Apex test. And then we'll click save, and all Apex action will come under tools. 6 of them are here. Think of this server like a menu in a restaurant. It is the list of things Claude is allowed to order. If it is not on the menu, Claude simply can't ask for it. So these 6 tools are Claude's entire menu in this org. It hands if you like. And here is the important part. Claude is smart enough to design a whole system on its own. But to actually change a real Salesforce org, it needs these hands. And we decide exactly which ones to give it. We are not handing over the keys to everything. We are granting a specific, safe set of abilities. That's the whole idea of MCP. The AI brings the intelligence, and we grant it preciously the capabilities we choose. Now, one really important step, and it is easy to miss. New servers are turned off by default, so we have to click activate. If you forget this, Claude will try to connect and nothing will happen. So activate. Now it's live, our Apex developer server. Now we get our second value, the server URL. This is the exact address of our server. We copy it straight from this screen. So now we have to both pieces, the consumer key and the server URL. That's everything Claude asked us for. So let's go back to the Claude and finish the connection. All right, this is the moment everything comes together. Remember those 2 values we made on the Salesforce side. Now we bring them here. First, I will give the connector a name. Let's call it hospital.org. Just so I can recognize it later. Next, remove MCP server URL. This is the first value, the server URL we copied from Salesforce after we activated our server. I'll paste it right here. Then I open advanced settings. Here's where the second value goes, the auth client ID. That is the consumer key from our external client app. I'll paste then that in here. The client secret right below displays, we leave it empty. Remember, we are using PKCE, so Claude doesn't need a secret. That's by design. And that's it. Just two values, a name, and we are done here. I will click add. And now Claude will connect to Salesforce. Okay, everything is connected. All 6 tools are right here, ready to go. Now, before I pass the prompt, let me say something about the power of the cloud. Because this part is easy to miss. Honestly, I could just type one sentence, which is build a hospital management system, and Claude will design the whole things on its own. It will decide the objects, the fields, the relationships, the code, everything. That's how capability is. It doesn't need me to hold its scent. But that's not what I am going to do here. And here is why. This is not a small project, it's big and detailed. Many objects, many fields, many classes, real automation rules, and for something this size, I want to be sure exactly what gets built. Down to each field and each rule, I don't want to be surprised. So instead of one-line request, I am giving Claude a long, detailed structure prompt. It spills out of the full data model, every field, the Kevin O'Hara automation rules, the coding standards, and even demo data to create at the end. To be clear, this is not because Claude needs all these details. It's because I want full control over the results. Claude has the power to fill in the blanks itself. I'm just choosing to remove the guesswork. So yes, this is a big prompt, not 2 lines. That's on purpose because we are building something real. And let's start and watch Claude build the entire hospital system. Right now we are in the Claude chat and Claude has just finished. In one single conversation, it built the entire hospital system, and here it's summarizing exactly what it did. 7 objects, 3 handlers, 3 triggers with Kevin O'Hara framework, task coverage all passing over 90%, and 19 records created, and a working app. But let's now just take its word for it. Let's switch over to Salesforce and see every single piece of this live in the org. Okay, I will open App Launcher and search for hospital management system. Here it is. A complete hospital management application, 7 objects across the top, departments, patients, doctors, room, appointments, prescription, and admission, all built from a single conversation in about 5 minutes. And it is not empty. A real demo data is already here. Cardiology is writing cardiology and location. Patients, when I open the Novosu, we will see that this age, phone number, email, all here. One example for Dr. Okafor, as you see, linked department already and writing email and fee here. And room is already linked with departments, and appointments links patients and doctors, and so on. Now let's look under the hood. This is schema builder, the entire data model as one diagram, 7 objects and every relationship between them. Room, doctors belongs to department. Room and doctor links department, and also appointments links patient and doctor, and so on. Claude designed this whole schema, the objects, the fields, and the relationships just from a conversation. Next, the code. This is Apex classes. We have 6 classes here, just Claude created, 3 handler classes and 3 handler test classes. I will open appointment trigger handler. As you see, we have extend trigger handler, that is Kevin O'Hara trigger framework, the industry standard open source pattern for organizing triggers in Salesforce. Instead of dumping logic into a trigger, all the logic lives in clean methods like before insert and before update. Right here, as you see, we have one method, prevent double booking list. Before an appointment is saved, it checks whether that doctor is already booked at the same time and blocks it if so. Claude didn't just write the code that works, it followed a real professional architecture. And here is the elegance of that framework. The triggers itself, the thing that fires when a record is saved, it literally one line. It just creates the handler and the calls run. Here is the run method. All the real work happens in the handler. That is the Kevin O'Hara pattern, 10 triggers with all the logic in the handler, 3 triggers here, each a single line. And to close the loop, here is the base framework class itself, trigger handler. Every one of our handlers extend this. It is the engine that decides which method to run before insert, after update, and so on. And it even protects against recursive loop with that setmax loop count method. This is the Kevin O'Hara's frameworks dropped into the org and used correctly. The whole automation layers is built on a proven foundation. Code that works is one thing, code that's proven to work is another. Every handler has a test class and each one checks both sides. That a valid record save and that an invalid one gets blocked. Let's run them. As you see, all green. Every test passes, 0 failures, and the all coverage is 93. All above the 90% bar Salesforce recommends. This is the production quality code with the test to back it up. But does the automation actually fire? Let's prove it live. I already have an appointment for Dr. Omaro Okafor on July 15 at 9 a.m. Let's check what happens when I try to book the same doctor at the same time for a different patient. New appointment, Amy Souza, date 15th of July, time 9 a.m. and Dr. Omaro Okafor, and I'll click Save button. And it's given an error. This doctor is already booked at the selected date and time. Please choose a different slot. The system stopped me that rule written in Apex by Claude is live and protecting the data in real time. So let's step back. In about 5 minutes from a single conversation, Claude built a complete hospital management system inside the Salesforce. 7 custom objects with all their fields and relationships, 3 trigger handlers on Kevin O'Hara framework, 3 triggers, test classes with over 90% coverage, 19 records of demo data, and a fully working Lightning app with business rules that enforce themselves. No manual clicking, no writing code by hand, just a conversation. That's the power of cloud connected to Salesforce through MCP. Thanks for watching.